In this lesson, we're going to go through significant figures. So once again, significant figures are quite important in the scientific world. The rule here is the number of significant figures is counted from the first non-zero digit beginning from left to right. So there's a couple of rules you need to remember. So all zeros after a decimal point is considered significant. So if I had 102.0, this zero at the end is definitely a significant figure, and so is the first three numbers. Okay, zeros at the end of an integer, so of a whole number, are not significant unless specified. So they can actually be significant or non-significant. So what do I mean by that? So let's say I have a whole number, I have 220. So this can be considered as having two significant figures. Okay, because it says here that the zeros at the end of integers are not necessarily significant, but at the same time, it can also be considered significant. So this could also be three significant figures. If that confuses you, you'll kind of get it a little bit later when we start to round, because so just know that if it's a whole number, if it ends in zeros, they can be considered significant, and they can also be considered insignificant. So here's some examples. So here we've got a number with 8 significant figures. That's assuming that the last 3 zeros are significant. If they're not considered significant, then we technically have 5 significant figures for this value here. This one has 3 significant figures because we always start counting the number of significant figures from the first non-zero digit. So this is 0, so that doesn't count. The first four numbers are 0, so they're not significant. This is the first non-zero digit, so that's significant, and anything afterwards, after a decimal point, is considered significant, so that's 3. And over here, we've got 2 significant figures when you look at this area here, 4.3. So let's see if you can work out how many significant figures there are in these values. So here, it's quite easy. As long as you're not a 0, you're considered significant, okay? And over here, there are 6 significant figures. Now, any zeros in between numbers are considered significant. So we start counting from the first non-zero digit, which is 1, and we count every number basically after that. Okay, so there's 6. Over here, there are 4. And over here, well, we don't include the 0 at the start because we only start counting from the first non-zero digit, which in this case is 6. So there's only 3 significant figures for this one. Over here, there's 4. The first non-zero digit is a 3, and after 3, it's just 2 more digits, so it's 3 in total. So 3, 4, and the final 0 there. Down here, we've got we've actually got 5 significant figures because any zeros after a decimal point is considered significant. The fact that you bothered to write, this is just 4.6, isn't it? The fact that you bothered to write 2 more zeros after it, even though it doesn't change the value of the number, means that these 2 zeros are actually significant figures. Over here, it's only 1 significant figure because the first 4 zeros don't count. Here, now this one can be considered as having 1 significant figure, or it could be considered as having 6. We'll get that. You'll start to understand that a little later. Just keep that in mind. Over here, we've got 6 significant figures. First non-zero digit counting all the way to the end, and that 0 at the end is significant because it's after a decimal point. And over here, that's 5 significant figures as well, because any zeros after a decimal point is considered significant. And over here, we have 6. Hopefully you got the hang of that. So let's start doing some rounding. So let's round the first number to 1 significant figure. So far there's 3. I'm going to round it to 1 significant figure, which means I don't want to make these 2 numbers significant. The best I can do for this one is write the number 900. That's rounding to 1 significant figure. Now remember, 900 can be considered as 1 or it can be considered as 3. But the best we can do to make it 1 is to make it round to 900. So we say that these 2 numbers aren't significant in this case, and only the 9 is significant. Okay, you can say that for zeros at the end of integers, but you can't say it for numbers at the end of non-zero numbers at the end. So there's no way in the way you can say, oh, let's pretend the 3 and the 2 are insignificant. You can only do that for 0. So that is why you can assume that this is 3 or just 1. Let's round this second one to two significant figures. So the first two numbers are not significant, so they don't count as part of the significant figure count. Then we have 5, 3. Now the 3 we round to a 4 because of the 9. We basically stop writing on this line or at this line. So we don't write anything after this line. Now the 9 makes the 3 a 4. So to two significant figures, it'll be 0.054. Over here, two significant figures again. So that's not significant. 6 and 5 are, and that's 2 already. That leaves us with 0.65. And then down here to one significant figure means we stop writing there. Any zeros at the start don't count. So rounding the 6 rounds to a 7 because a 7 will make 6 a 7. So that will be 0.0007. Hope you're getting the hang of this. Here to three significant figures, well, 8, 6, 4 are significant. We're going to stop writing there. So the number here would be 86.4. This next one here is for three significant figures, we stop writing there. And that's going to be 613 because the 7 after the decimal will make the 2 a 3, rounded up to a 3. This next number to three significant figures means we cut it off here, and it's going to be 45.4 because the 3 makes the 4 stay. This number to one significant figure. So here's the trick here. Now, we don't want to change the value. Some students would be like, well, one significant figure means I only write one number. That's not true, because if you write one number, let's just say you round the 8 to a 9, the number 9 is nowhere near 9,000. Okay, so it's nowhere close to this number. So the value still has to be approximately the same. Just like when you round decimal places, it has to be approximately the same. So you would never do that. So the reason why we can write this as 9,000. That's the best that we can do in this case, and it can still be considered as one significant figure is because of that flexibility. We can count this as 1 or 4. In this case, the best we can do for 1 is to write it as 9,000. Down here, one significant as well, which means we stop writing there. That's going to give us 0.008. 7 makes the 7 and 8. The 7 here after the 7 makes a 7 and 8, if that makes sense. And finally, two significant figures. Stop writing there. The number's just going to be 13 when rounded. Okay, so let's combine significant figures with scientific notation. So we're going to write these basic numeral, or they call them decimal numbers in the textbook, to scientific notation. So we want to write it in scientific notation as well as having three significant figures. So let's begin with realizing where the significant figures are. So we know that we don't write any more than 987 basically. So we pretty much ignore the rest of those numbers. Now in scientific notation, we've got to move the decimal point. Now I know this is going to be a big number, so my index is going to be positive. I'm going to move it back 1, 2, until I've achieved a number between 1 and less than 10. So 9.8 is where I'm going to be. 9.87. We stop there because that's already three significant figures, and we're going to multiply this by 10 to the power of 6 because we've jumped the decimal point 6 times. Okay, so that's scientific notation to three significant figures. This is really important when you get to chemistry and physics, where you do a lot of maths in science. Number 2. So to two significant figures, I know I stop writing there, and I know that the 5 is going to make the 4 a 5. So let's just move the decimal point to make it to scientific notation first. So 1, 2, 3, 4. I stop here, 5. That gives me a number between 1 and less than 10. 3 point, instead of writing 4, I'm going to write 5 because it's going to round it up. That's two significant figures. And don't forget the scientific notation, 10 to the power of negative 5. It's a very small number. Over here, four significant figures. Basically, every number that you see here stays. I'm going to write it to as a scientific notation. So 1, 2, so 8.376 times 10 to the negative 2. Negative because it's a small number. And over here, last one, three significant figures in scientific notation. So I'm going to move the decimal point back 3 times. I know it's going to be 5 points, and it's only we only want 3 significant figures, so 5.67 is as far as I'll go, times 10 to the power of positive 3. And that's it.